For this fluency activity, we're dividing fractions again, but you'll want to change the mixed numbers into improper fractions before completing the division. So the way I do this is 3 times 3 is 9, and then I add the numerator. 9 plus 2 is 11. 1 times 3 is 3, plus the numerator makes 4. But remember, when we're dividing fractions, we use that leave change to multiplication, and then we change the fraction by flipping it over. So 11 times 3 is 33, and 3 times 4 is 12. You can see here that 3 is in both of them. So this one can be reduced. 3 times 11 makes 33, and 3 times 4 makes 12, so that one can be reduced to 11/4. If you are requested to put this as a mixed number, 4 fits into 11 2 times, because 4 times 2 makes 8. And then from 8 to 11, we would need 9, 10, 11. That's 3 extra pieces, giving us an answer of 2 3/4. Either of these are acceptable. This is the improper fraction format, and then the mixed number format. Noor takes daily walks. The distance Noor walks in miles is proportional to the amount of time she walks in hours. That phrase proportional came from yesterday's lesson, where we talked about them having the same unit rates at every step in the process. It says the table shows how long it takes Noor to walk varying distances. Use a method of your choice to determine the number of miles Noor walks per hour. That's considered the unit rate. We are going to divide to find the miles per hour. That tells us the order to divide. So we'll take the miles, because that was mentioned first, and then divide by the hours, because that was mentioned second. So 3/4 divided by 1/4. We leave the first fraction, change the symbol, and change the second fraction. 3 times 4 is 12. 4 times 1 is 4. And 4 fits into 12 perfectly 3 times. So the number of miles they walk per hour is 3 miles per hour, meaning that they walk 3 miles in 1 hour. For each table that represents a proportional relationship, write a description by using ratio language for each of the other tables. Explain why it does not represent a proportional relationship. Now, since we do not know that these are proportional, that's part of our job, is to determine if they are. We're going to have to check multiple rows in the table to check and make sure that they come out to the same unit rate. We can change these fractions into decimals if that makes it easier to work with. 2 1/2 can be rewritten as 2.5. If we multiply by 2 for this fraction, we would get 4 2/10. 2/10 can be rewritten as 0.2. Now to divide, we're going to check and see if they all have the same unit rate. We have 26.25 divided by 2.5. Remember, we've discussed that strategy where we can turn these into a whole number by moving the decimal the same number of spots. So now we're looking at 25, and that fits into 26 one time, leaving us with 1. 25 does not fit into 12, so we'll put a 0 there and bring down the 5. Make sure your decimal is lined up. 25 fits into 125 5 times. So this first one has a unit rate of 10.5. Let's check another spot to see if it's the same at another place in the rows. Here I had 44.10 divided by 4.2. We'll move those, changing this to be 42 and 441. 42 fits into 44 once. If we subtract, that gives us 2. 42 does not fit into 21, so we put the 0. The decimal is now here. And we'll bring down another 0. And 42 fits into 210 5 times. So this one does have a constant unit rate. We would want to check all rows to make sure. You can do those in your own time or using a calculator to verify that they are correct. And then since it is proportional, we need to describe using ratio language. This means that for each hour, they earn $10.50. You could also phrase it as for each hour, they earn $10.50, or for 1 hour worked, or 1 hour walked, they earn $10.50. Now let's look at the table for B. We can write 7 and a quarter. A quarter is worth 25 cents. So we could write this as 7.25. 3/5, if we wanted to turn it into tenths, that would be 6 tenths. So 5.6. Let's divide to see if these have the same unit rates. Let's use rows 2 and 3 this time. 210 divided by 3.5. We'll move that decimal one spot. So now we're working with 35 and 2,100. $35 doesn't fit into 2 or 21, but it does fit into 210. And that should be 6 times. And that comes out to exactly 210. So we still bring down the 0, and we need to finish it off. This one has a unit rate of 60. Let's verify that the next one comes out to the same. If it does, then it's proportional, but if it is not, then it is not proportional. Four doesn't fit into 2, but it does fit into 26. 4 times 6 is 24. That leaves us with 2. Bring down the 0. 4 fits into 25 times. Those unit rates are not the same, so this one is not proportional. And then the reason is because they are not the same unit rate. These rates are not the same. C. We can also work with them in fraction form rather than decimal form, but I prefer the improper fraction version. So 5 times 2 is 10, plus 1 more makes 11. And then we keep the denominator that it started with. 8 times 4 is 32, plus 1 more makes 33. And again, keep the denominator. 13 times 4 is 52 plus 3 makes 55. 27 times 2 is 54, plus 1 more makes 55. Now for dividing, remember we're doing the flour per loaf. So we want to divide 11 over 2 by 2. All of these whole numbers have that invisible 1 underneath. And we're going to leave, change, change. 11 times 1 is 11. 2 times 2 is 4. So this one has a unit rate of 11/4. Let's look at the next one. 33/4 divided by 3. Remember, there's an invisible 1. Leave, change, change. 33 times 1 is 33. 4 times 3 is 12. But a 3 goes into both of those. If I split 33 in 3 parts, each one would have 11. If I split 12 into 3 parts, each would have 4. So far, these are the same unit rates. You can check the last two on your own to make sure those also come out to 11/4. They do. Oops, I'm on the wrong slide here. They do, so they are proportional. And we need to write a statement about their relationship. Every 1 loaf of bread uses 11/4 cup of flour. This is our ratio statement, 1 loaf and 11/4 cups of flour. For D, we can divide the miles by the hours. Remember, we leave, change, change. 1 times 12 is 12. 4 times 1 is 4. And 4 fits perfectly into 12 3 times. Let's check the next row. Leave, change, change. 1 times 6 is 6. 2 times 1 is 2. And 2 fits into 6 exactly 3 times. And the last one. Leave, change, change. 3 times 4 is 12. 4 times 1 is 4. And we already said 4 fits into 12 exactly 3 times. So this one is proportional. And we can say that for every 1 hour, they walk 3 miles. With this one, if we divide the students by the teachers, 5 divided by 1 is 5 for this first row. But then the next one is 4 divided by 1, which is 4. So this one is not proportional. And these also do not have the same unit rates. One divided by 2 would be a half. 3 divided by 2 is 1 1/2. So none of the rows have the same unit rate. We can look at these fractions. 5 divided by 1/4. We leave, change, and flip it over. 5 times 4 is 20, and then there's that 1 underneath. For this one, the fraction 5 times 5 is 25, plus one more makes 26 fifths. So we have 104 divided by 26 fifths. Leave, change, change. 104 times 5 is 520 divided by 26. Well, does 26 fit into 520 exactly 20 times? Let's see. 26 times 2 is 52, which leaves us with no leftovers. So it does fit in 20 times. These have the same unit rate, so it is proportional. And we can say that they earn $20 for each hour walked. Three, Nora has a part-time summer job. The amount of money she earns is proportional to the number of hours she works. So it's telling us right away that every step in the table is going to have the same unit rate because it just said the amount is proportional. The table shows the amount of money Nora earns for different numbers of hours worked. Write an equation that shows how much Nora earns at her job. Let H represent the number of hours worked and D represent the amount earned in dollars. So to write an equation, we use the unit rate. Since it's proportional, we can use any row in the table. I'm going to work with this one since it has a whole number. 5750 divided by 5. 5 fits into 5 once with no leftovers. So then we would have the 7. 5 fits into 7 once. 7 minus 5 is 2. Bring down the 5. 5 fits into 25 5 times with no leftovers. That means she earns $11.50 for each hour worked. If we started with the hours, we would multiply by $11.50 to get the dollars. So we want $11.50 times the hours to equal the dollars earned. Now it says in part B to use the equation to determine how much she would earn for working 3.5 hours. That's going to go in the H position. So $11.50, and we're replacing the H with 3.5 to figure out how many dollars she would earn. We can rewrite that as a decimal. 3.5 is the same as 3.5. And now we need to multiply to calculate how many dollars she would earn. $11.50 times 3.5. 5 times 5 is 25. 5 times 1 is 5, plus 2 more makes 7. 5 times 1 is 5. Now we're going to put that place value spacer and multiply by 3. 3 times 5 is 15. 3 times 1 is 3, plus 1 more makes 4. And 3 times 1 is 3. Now let's add those up. 5, 12, 10, and 4. There's 1, 2 decimal spots in the question, so we need 1, 2 in our answer. That means the dollars she earns is $40.25. Do you think she will have enough money to purchase the almonds? Think about how much money she had, the price per pound, and how many pounds she purchased. Now let's watch part 2. Looking at problem 4, it says the cost of almonds is proportional to their weight. Eve pays $2.50 for a half pound of almonds. Determine the cost of different weights of almonds listed in the table. If she pays $2.50 for half of a pound, how much would she pay for 1 pound? Well, a full pound is 2 half pounds. So we would have 2 sets of $2.50, which would give us $5. That's for 1 pound. Now we need to figure out how much she would pay for 1 3/4 pound. Well, 1 3/4 can be rewritten as 1 times 4 is 4, plus 3 more makes 7. If 1 pound is $5 and we need 7/4 of a pound, we can multiply those together to figure out how much it would be for 1 3/4 of a pound. 7 times 5 is 35. 4 times that invisible 1 is 4. 4 fits into 35 8 times because 8 times 4 is 32. Then from 32 to 35, we need an extra 3. 8 3/4, 3/4 is worth 75 cents, so we could write that as $8.75. B says to write an equation that represents the cost of different weights of almonds. Let A represent the weight and C represent the cost. If we start with the weight, A, we had to multiply by 5 to get the cost. Now it says use the equation we wrote from part B to determine the cost for 2 1/4 pounds of almonds. We're replacing the A that represents almonds with 2 1/4. So 5, swap out that A with 2 1/4, not a half, a quarter, and determine the cost. Well, we can rewrite 2 1/4 as an improper fraction. 2 times 4 is 8, plus 1 more makes 9. So we could rewrite that as 9/4. And remember, we're multiplying. 5 times 9 is 45. And there's that invisible 1 down there. 4 fits into 45 11 times. 4 times 11 is 44, plus 1 more makes 45. So the cost would be $11.25 because a quarter is worth 25 cents. Go ahead and think about these debrief questions as you wrap up your lesson. Go ahead and check back for lesson 4 coming soon. You may also want to add some information to your graphic organizer on page 19 of your workbook to help you learn and understand more about proportional relationships. Include some information from today's lesson to help you.